Let's explore some more features of Sage, in particular how to plot things in Sage. So to plot things in Sage, well, we're just going to use the plot method. And so let's plot a function x minus 1 squared from for x from 0 to 4. Okay, and so there we get a nice looking plot. Sometimes you might want to actually label the axes, and so you can do that within Sage. You just have to define them in this way, labels. And we want x and y for the x and y axes. And so there we go. We have nice looking labels there. There's a nice feature within Sage, which is called the interact feature. And so the way we call this is we say at interact. Now we want to define something that we're going to be able to change, call it u, and u will vary between 0 and 3. And what we want to show with this interactive feature, well, we want to plot this function x minus u squared for x from 0 to 3. And we have to put this show out front in order for it to work within interact. Okay. One thing that commonly happens is people might forget this colon here, so don't forget your colon. And so the interact feature in Sage allows you to, well, here's a plot where u now is set at 0, and then you can drag this slider and get different values of u and regenerate a new plot for each different value of u. Okay. So that's a kind of a fun little feature within Sage that's useful to know. Within Sage, if you want to know of a new function or something that maybe you haven't seen before, well, you can always start typing what you want or what you think you might want, and then hit Tab. And what will come up in Tab is a list of all of the possible functions and methods within Sage that start that way. So not only plot, but plot 3D, plot 3D using a different package. You can do slope fields, which we'll talk about. So let's talk about a 3D plot. And so if we want to do a 3D plot, let's do x squared plus y squared. We have to give x and y values for that to be valid. Now, if we just try this, it's going to give us an error because y is not defined. We haven't defined y as a variable. And so let's just be sure to define that for both x and y. And we do a 3D plot, and then in our 3D plot we get a 3D plot here that we can drag around with our mouse. You can zoom in with the cursor or with the wheel, or you can zoom out. And so you can manipulate this 3D plot as you wish. You can, in addition to doing 3D plots, you can do contour plots. So let's define a function f of x and y, which is y squared plus 1 minus x cubed minus x, just some random function. And so now let's do the contour plot. So I did con, and then I hit tab to find contour plot there. Sometimes a quicker way than actually typing things in. X from -2 to 2, and for y from -2 to 2. Let's turn labels on. So we'll say labels is true, so we can see what the labels of the contour is on. And then there we have a nice fancy looking contour plot of this function. You can change the colors that are used. Here we're just using black and white. Let's change the color scheme to something called the cool color scheme. All right, that looks kind of pretty. And you can look up various different color schemes by just Googling to find different color schemes within Sage. Okay, let's do a slope field plot. So plot slope field, which is something that often happens in mathematical applications, particularly for solving differential equations. Let's do sine of x plus y plus cosine of x plus y. X from -3 to 3, y from -3 to 3. And Sage will then plot the appropriate slope field for this function. If you have a vector field instead of a slope field, you could do a vector field as well. So we want to do a 2D vector field. So we'll do plot vector field. And in order to do a plot of a vector field, we first have to put in the vector field that we have. So here our vector field is -x, y. I want to do that from x from -1 to 1, and for y from -1 also to 1. And we get a nice looking vector field plot. In addition to all these types of plots, we can do parametric plots. So let's define a variable t to be our parametric variable. And let's do a parametric plot. And the parametric plot we'll do is x is equal to t, y is equal to t squared. And we'll do that for t from 0 to 4. And there we have a parametric plot. You could do a 3D parametric plot, which shows up as well. So let's do a 3D parametric plot. And for a 3D parametric plot, of course, we need to give 3 entries here. Cosine t, sine t, and then t over 4. And let's do this for t from 0 to 4 pi. Don't forget the star there. Okay, and now we have a 3D parametric plot of what looks like a helix. Okay. We could also do a 3D parametric plot which generates a surface. So let's define u and v to be variables. And we'll do a parametric plot, 3D. And so in this parametric plot, I'm going to have both u and v as variables that can vary parametrically. And I will vary u from 1 to 3, and then v from 0 to 4 pi as well. And so we have our 3D parametric surface. Looks like this. If you want, you can turn on the mesh that's being used, which might give you some sense of the texture of the surface. Okay, so that's the basic of plotting within Sage. Of course, you can Google other things to see all of the other wonderful things you can do within Sage.